Hello everyone, welcome to the edureka sponsored Hadoop for Data Warehousing webinar. It's me Madan Mohan. I'll be your guest speaker for walking you through this presentation. So I've been working as a chief architect in travel industry for more than 7 to 8 years. Prior to that I used to work on e-commerce platforms, and also my previous roles include co-founding in startups and leadership managing and engineering deliverables about me. So you could always get connected to my LinkedIn just to know a little bit more about it. So just a little bit brief on the logistics part of it. So most of the time we'll be just walking through the course content. Just in case if you wanted to stream any questions, so use the Twitter handle provided at this slide. Ask edureka for any questions now or to follow up in future. So I'll be taking up this session for roughly around 50 to 55 minutes, and we'll keep 5 to 10 minutes at the end for any Q&A. Since we have a large audience, I'll restrict the Q&A for at most to the most important questions what I could pick up, handpick, and see if I could answer for 2 or 3 of them. And remaining we could take it offline through the edureka stuff. Okay. So let's get started. So here is a quick rundown of what we're going to cover today. So we're going to understand what big data is all about, and what is the hype of big data, and what is Hadoop, and where does the traditional data warehousing fit into this equation. How does it conflict with the traditional data warehousing platforms or the commercial solutions available as of today, and what are the challenges and pros and cons of each of these solutions compared to Hadoop. And then we'll talk about how data warehousing can leverage Hadoop, or how Hadoop can be integrated into the enterprise data warehousing platforms. And then we'll talk about details, a bit basics of what Hadoop is, what MapReduce is all about, and then we'll try to end up with a real world scenario and conclude with what to use when kind of a situation. So most of the newcomers has this big question, so whether I should go for Hadoop analytics platform or go with a traditional or a conventional enterprise data warehouse platform. So we will try to put a discussion and debate and conclude with that. So the final objective of this presentation, you should be able to get basic amount of idea on Hadoop and what is the difference between a traditional enterprise data warehouse platform and when to use what. So that's the objective, what we're going to achieve in this 1-hour session. Okay, so quickly let's start understanding what is big data. So the biggest question I keep hearing from majority of the audience, whomever I interact with, so the biggest confusion for the newcomers is whether big data is a technology, or is it a term, or is it a hype, or is it a buzzword kind of a situation. So definitely big data is not a technology. It is just a term which used to define volume of the data, as simple as that. So it is not a technology, it is not a platform, or it is not a solution. So it's just a term used to refer the volume of the data in very simple and in very straightforward definition of what it could be all about. Okay, so a little bit more digging into the definition of it. So big data could be collection of large data sets. When I say large data sets, it could be contextual. So a large data set could be terabytes or petabytes of data. So that's what I would mean as lots of data or large data sets. And moreover, when you have this more complex data structures within that large data sets, so it becomes really difficult to handle or manage to process that kind of complex and huge volumes of data using conventional RDBMS technologies and conventional data warehousing platforms. So that's when the big data technologies or the big data platforms comes into rescue to help the processing of volume and the complex data types or the complex data structures. So some of the challenges what you would usually find in the big data scenarios is the challenge is to capture the huge volumes of data would be one of the most challenging things. So when I say capture, so you have to aggregate all the data from different sources and retain it for a longer period of time to get any business insights or to run into any business reports out of that data. And also if you have to do any sorts of transformation, or you have to cleanse that data, or you have to normalize that data on a big scale, it really becomes challenging for you to do that kind of job on a conventional approaches. And also storing it, sharing it, that kind of data, and on top of it, if you have to do analytics, so that's some of the challenges what you would usually come across. So these are the challenges what usually you would find, so that people came out with different approaches to handle big data and to process big data, store big data, and manage big data in a different ways. So all said, so big data also is not only related to Hadoop or any specific technology. So it is a term. So there are a lot of technologies, lot of platforms, a lot of solutions being offered as a big data solution. So big data always does not map to Hadoop, or Hadoop is not always tied up to big data. So that's another confusion what people come up with and say, hey, big data is all Hadoop. So no, that's not the case. So Hadoop is a framework or a platform which can handle big data problems or big data kind of a challenges. So apart from Hadoop, there are different technologies, just like NoSQL technologies like Cassandra or any other NoSQL storage solution or cloud. All of them are capable of handling big data. So I hope that gets cleared so that we don't get into the confusion of what exactly the big data is all about, or whether it is always tied to Hadoop or not. So straightforward, it's not. Okay, so a little bit more digging into big data. So why big data is gaining momentum in the recent years, or why is it being exploded into a lot of discussions and a lot of forums, and why it has gained momentum in the last decade or so. Few reasons. So digitization growth. So the big data started gaining momentum because of a lot of organizations got the capability of digitizing their platforms and digitizing their solutions or systems, which eventually started generating a lot of data. So the moment you start generating a lot of data, you'll see an exponential data growth in the internet or on the IT sectors or on, say, any domain for that matter. So the biggest thing what you would notice in the recent decade or so is the digitization, which has triggered the data growth, and the data what has been emitting was so complex and unstructured. So on the slide you would notice, so the relational or the structured data growth was very saturated, and it was very normalized kind of a growth. When it comes to the digitized, unstructured or complex data, you would see tenfolds of exponential growth which happened in the recent years, which was a drastic change. So people started to explore the data what they are aggregating or the data what they are emitting. So, and when you have the affordability of the storage solutions and the computing solutions, which was not possible in recent times, say for example a decade back, we could not afford a 1 petabyte storage solution that easily. So very few organizations or research organizations or government organizations were able to compile or build up that kind of a scale, massive scale of storage. But today, petabyte scale is accessible or affordable even to a smaller to a medium-sized organizations who could spend, say, for example, a few thousands of dollars. They could afford easily a petabyte storage for storing their data. Okay, so that was not the case few years back. So the affordability of the storage and the computing has enabled the data growth and the data digitization aspects of it. And moreover, the business now wants to leverage the data being generated by analyzing the data and getting insights into that data and try to drive more business revenue for their organizations. So these are the few things what has really got big data into limelight. So just rough numbers. So you would find roughly around 3 hexabytes of information or digital data which is lying in the computers today, as of today. It is just a rough number. It is not the absolute or exact value. So I'm just making a rough guess, around 3 hexabytes. And also a few numbers like the digital universe started to grow exponentially by 60 to 70% with few hundreds of thousands of petabytes, and it is expected to grow to zettabytes in the near future, or it would have already reached to maybe even 2 or 3 zettabytes in the near future. It shouldn't be a surprise. So just a quick numbers on how big data is playing and how the big data is being transforming the world today. So most of you, those who are on the Facebook analyzes and stores more than 50 petabytes of user-generated data. It's just a rough number, and companies like Akamai, they have more than 100 million events which has to be aggregated and which has to be analyzed to target better revenue management using their ad management. So there are different combinations of data management, data analytics which companies used to do. So I'm just giving some numbers to just get the feel of it. So companies like Google, they have to index the entire web over the period of time. So they have to go and scan each and every web page, analyze the document, store the TF, IDF weight factors, and then index it, rank it. And it is a huge data volume for us to crunch on periodic basis. So Google does it again in petabytes or in kind of big volume. So these are all the kind of scenarios where you will come across big data where it has been exploding in recent times. Okay, so not limiting the conversation to certain aspects like Google or companies like Facebook kind of a thing. So before jumping on to other scenarios, the biggest thing what we have to underline here is, so the world's technology capability of adapting capacity of computing or storage has roughly doubled in the last year and a half or last couple of years. So that is the primary reason where you would see, or the standard thumb rule says every 2 years the organization's capability or the feasibility of adapting technology storage or technology computing increases by roughly around 100 to 120%. So that's one of the reasons why you would see a big data jump happening all of a sudden. Okay, so it should not be also treated that big data is always related to companies like Facebooks of the world or Google. So there are a lot of domains where you can aggregate a lot of big data and analyze that big data to drive some useful business benefit or real value out of it. One such example is, say for example, if there are a lot of hospitals who want to track and monitor the patient's historical diseases, historical medications, and try to keep all those historical records and analyze it over a period of time to make recommendations or treatments for those patients who could be predicted for any abnormalities even before it could happen. So those are the huge challenges for the healthcare sector, where people have to keep all the records for, say, 20 to 30 years when a patient gets enrolled, and keep analyzing those records over the period of time and recommend right treatment so that they avoid costly hospitalization kind of a scenario. So it also helps the insurance companies to go ahead and make the right investment or the right insurance policies to the patients. So this could be a lot of scenarios where the healthcare sector can also be leveraged. So just a quick example of how we could also do that in healthcare sector. Okay, so when it comes to Amazon, so most of you would have already used Amazon for shopping, buying such stuff. So Amazon banks on the huge amount of customers interaction, customers behavior, and what they have done in the past. They collect all this information, they aggregate all this information over the period of time, and they make the right recommendations or the right choices for you to choose based on your historical behavior or based on your similar user behavior on similar products. So there are different things like people like Amazon practice. So they store all the interactions between customer to customer relationship and customer to product relationship and make the right recommendations so that you could get a better choice of what similar things has been done by a similar user. So they predict the user behavior and make the right recommendations to the users. To store all the user interactions and to make the right recommendations, you need a huge scale of data volume storage which has to be persisted across users and across all the millions of products they have in their store, and then go ahead and run, say, analytics on top of it and make the right recommendations. So Amazon uses all the big data storage and also the analytics big time so that you could get right recommendations and right choices for your shopping experience. Okay, so another example, I'm just trying to cover a few real world scenarios so that you could get a sense of where people are using big data and analytics. So Netflix again uses big data Hadoop data warehousing platform, which is a petabyte scale again. So Netflix has all this information which is gathered from the streaming events or from all the Netflix enabled devices, the televisions, laptops, and all the mobile devices on a hourly basis. They capture all these information and they store all this information on different storages like S3, Cloud, and Cassandra. All these are all the big data solutions, and then they run multiple clusters of analytical platforms like Hadoop. They run elastic MapReduce clusters on top of the S3 storage, and they provide a lot of insights into the business reporting, and they make a lot of business interactive queries for all their applications. So they have multiple EMR clusters, which is like 500 plus node kind of clusters which Netflix currently leverages or Netflix currently uses. And some brief stats of how Netflix has streamed the Avatar movie reported to be storing all that information required to stream, and also how big data solution is required to render the Avatar 3D CGI graphics. So just a very brief introduction about some of these things. Okay, so quickly getting into some of the formal definitions of what big data is all about. So IBM has this formal definition defined in 3 or 4 V's, and in some cases more than 3 or 4 V's. So we'll stick to 3 V's. So big data can always be referred to as volumes. So when you have massive volumes of terabytes or petabytes of information, that can qualify to be a big data kind of a scenario. So sometimes it's not always required that it has to be a volume. So what IBM says is it also has to be velocity. Sometimes in some scenarios, processing a huge volume of data in say 20 minutes may be too late, right? To get some insights to a mission critical application, 20 minutes may be too late. So velocity is also a key factor in deciding a big data platform and a big data solution in most of the cases. So when it comes to variety, so there can be variety of content. It is not always it has to be text-based content or a HTML file content to index the web kind of a thing. So your solution may change based on your big data whether it is video content or images or sensor data or web logs or audio files. So it has to be capable of handling variety of data. So if you have a big data which is covering all the three V's, and also your solution is capable of handling all different aspects of these three V's, then it is referred to as a big data solution. So also there is another V, sometimes people call it as veracity. So the fourth V is veracity. People try to refer, it should have some sort of support to have hybrid integration models. Say for example, it should be able to integrate with the databases or any other conventional technologies so that it could offer the hybrid kind of a solution or a hybrid kind of a platform. So put all together these three V's, you can define a big data solution by identifying these characters or identifying these attributes of the solution. Okay, so if you have any confusions, follow these 3 or 4 V's and see whether this falls into this big data tag or not. So you could pick up any solution and see if it falls into all these 4 categories, and you could define or classify this as a big data solution. So as simple as that. So I could use this as a technique to identify whether this is a real big data solution or not. Okay. So let's quickly jump on to how traditional data warehousing solutions are built around in the enterprise world. So traditional enterprise data warehousing is built on top of databases, relational databases, right? It is used to aggregate all the data from different sources, like say CRM, ERP, or OLTP applications, or SCM, or any legacy platforms. So from all these data sources, the first step is to instrument all these data sources and aggregate all these data sources using some sort of ETL tool. So when I say ETL, the definition of ETL by intuitive, it is extract, transform, and load. The first step is to extract all this information from different sources, have different connectors, have different channels where you can extract all this information, and then do some sort of cleansing or do some sort of transformation. So you could do a lot of cleansing, you could do a lot of data transformation based on your requirement of what data you're looking in from these different data sources. So there could be a cleansing or a transformation step required after extracting the data. Once you extract and cleanse or transform the data, most of the time we do the loading of the data into a much more persistent storage where we can create business intelligence reports and run the business intelligence reports on top of that storage platform. So most of the time the storage of the extracted, transformed, or cleansed or loaded data, what we call it as the data warehouse. So this data warehouse can run simple ad hoc queries based on fixed schemas. So you cannot have flexible enough to load unstructured or unmapped data to a schema. So you need to have a schema in your data warehousing platform, and you can map that incoming extracted data, transformed and cleansed data into a schema which is already identified to store that information, right? So this is what most of the time it happens in a traditional data warehousing integration. So there could be multiple steps of ETL in between it actually goes and sits into the actual data warehouse or the actual data mart. So there are tools like what people used to use like Talon, Mule, Kettle, the traditional ETL tools which used to support components or programming model to do this kind of 3 aspects: extraction, transform, and load. So most of the time using these kind of tools has some sort of challenges. So the first thing is it is time consuming. The reason why it is time consuming is basically, say if you have one ETL job and you have to redo that for a different project, you have to redo that from the scratch most of the time. You cannot just say, okay, this is my data, start writing the business logic of it. You need to do a lot of boilerplate integration of connecting all these components or scripting all these components to extract, transform, and load. So there could be a lot of integration layers which are very tedious to code and which transforms the data from one layer to the other layer. And sometimes each layer might start stripping out or transforming the data into operational data store. Before it goes and sits into the operational data store, or sometimes we even call it as a data mart, on top of which we do the actual business intelligence querying. So a data mart is a small piece of database or small piece of business objects which are stored into a database, on top of which you can run ad hoc queries so that you can get business insights into it. So basically there are some commercial or conventional software or platforms or solution offerings like Teradata, Hexadata, and Netezza. So all of them offer the conventional way of handling the data warehousing. Sorry. So one thing I would like to bring it as early and as quickly as possible. So here we are not trying to make a recommendation to replace Teradata or Oracle or any Netezza kind of conventional or traditional platforms, but rather we're trying to understand when to use what. That is our objective, because both of them serve two different purposes. So we'll talk about what are those pros and cons in a while. Also we'll see what is the best to choose when we have to use a different thing. Okay, so when it comes to a few of the challenges what you would see with the traditional data warehousing solutions. So the traditional data warehousing platforms or solutions are built on top of the relational database or relational database systems, or on the concepts of RDBMS. So one of the challenges what you would ideally face with the RDBMS when your data warehousing platforms are built on top of it is, as your data volume increases or as your data volume grows, you cannot scale unlimited data storage, or you cannot do a horizontal scaling with the traditional RDBMSs. That's a true fact, and you'll see a lot of challenges in scaling that to unlimited storage when you use a traditional RDBMS to build your data warehousing platform. That's first thing. And the second thing is basically you will also see there is a lot of focus or emphasis on scaling up or doing a vertical scaling with the traditional RDBMSs. What I mean is basically the focus or emphasis on the traditional RDBMS solutions is to build a very powerful standalone machines with, say, lots of RAM, lots of storage, and lots of centralized computing kind of environment. So when you have to scale out, it is not a feasible option because database concepts are built and focused on building centralized storage rather than decentralized storage. So the primary focus of RDBMS is to have centralized storage and vertical scaling kind of a concept where you will get the strong consistency needs and you will get low latency read or write requirements. Both of them serve two different purposes. So those are the challenges you face. You'll not be able to scale out or do a horizontal scaling, and you'll not be able to do a scale out approach where you have to invest a lot of resources in doing vertical scaling when it comes to traditional RDBMSs and data warehousing platforms built on top of that. And also you cannot build with a cost-effective way. So if you have a huge data need on which you have to build your enterprise data solutions using the conventional RDBMSs, you have to shell out a lot of money and a lot of investment is required. So traditional data warehousing is very well suitable for OLTP kind of applications where you have to have all those acidness or low latency and all the SQL and say SQL kind of requirements. In some cases, it is also suitable for OLAP kind of a thing. So Hadoop comes in and solves a different problem altogether, which we'll be talking into details pretty soon. The pros of building enterprise data warehouse solutions is, like, as I mentioned, you can perform a bit of ad hoc queries on structured data with very low latencies, and it is fully SQL compliant, and it only works very well with the structured data and structured schema, which you have to be figuring it out upfront even before you decide what is your data query needs. Hadoop works a little bit totally different. So if your need is to go with real-time querying and real-time processing, so maybe enterprise data warehousing solutions fits into the bill. But if it has to be more of an unstructured data, huge volumes of data, cost-effective solution, and if it has to be capable of managing unstructured, unschema or flexible schema kind of a structure, then you need to look out for something different. Okay, so that's where Hadoop fits into the bill. So Hadoop is the right solution if you have some challenging situation which you cannot manage it in traditional RDBMS built enterprise data warehousing platform, as we have been talking of some of these challenges. So maybe it's time for you guys to go and explore Hadoop. This is the right tool where you can build unlimited scalable solution for storage and distributed processing or massive parallel processing. When it comes to RDBMS is not built for conventionally, it is not built for massive parallel processing. So it is built for concrete centralized processing kind of approach. So there are two different things. Okay. So just to give a quick overview, you don't need to worry about the licensing or the commercial aspects of Hadoop. Hadoop is an open source system where it has complete ecosystem of frameworks and platforms which can help you build a full-blown robust enterprise data warehousing platform to aggregate information, organize information, store, sort, sharing, analyze, visualize structured, semi-structured, and unstructured data as well. So Hadoop gives you the unlimited scale. So when I say unlimited scale, to an extent it is not infinite, but you can scale to whatever the needs your business has a requirement to store the information and process that information. To say a few thousands of servers to even up to 10,000 to say 15,000. So the practical use case what I'm aware of is people trying it out with 15,000 nodes cluster to sort a petabyte of information. So that's what I'm aware of. So technically you should be able to grow as big as possible. So there should not be any limitations. That is not possible in the traditional data warehousing solutions where you cannot scale to that volume. Okay. So one of the differentiators, what Hadoop makes it different, its ability to store large volumes of data and do massive parallel or distributed processing on those distributed clusters or distributed nodes in the cluster. And it also provides exceptional performance when you have distributed massive processing, parallel processing, so that you could use commodity hardware to build up those clusters. You don't need high-end machines or vertically scaled machines. So you can use commodity machines to build a huge storage cluster or a huge processing clusters. So it is not required that you need to always go for a high-end machines in your cluster. So the initial insights I would recommend you to do is try out Hadoop. You will always find Hadoop cheaper than my guess is 20 to 50 times cheaper than your traditional or conventional enterprise data warehouse platforms. Okay. So few more things. Hadoop does not replace the conventional enterprise data warehousing platforms, or it does not replace ETL tools like Talon or Kettle or anything of that sort. It is another channel to do the ETL kind of a job to extract, transform, and load information into storage solutions. Okay, as said, it is another channel. So also Hadoop is not a ETL tool. So don't treat or think that Hadoop is a ETL tool. It is a platform that supports running ETL processing in parallel or MPP fashion or in a distributed way. And moreover, I also wanted to stress Hadoop may not replace RDBMS. So don't have this thought process that, okay, Hadoop can replace the RDBMS based solutions. No, they are two different solutions built for two different needs, and each one of them has different things when it has to choose based on the use cases or based on the scenarios what the business is trying to work with. Okay, so little bit details. So as I mentioned, Hadoop is an open source framework. It has got two core components. One is the HDFS and the other one is the MapReduce. I'll just briefly explain what are these topics. Before that, so you would sometimes you would notice that you would have seen the little small yellow elephant. So it's a brand ambassador of Hadoop. So the name Hadoop was given by the inventor, Duck Cutting, by taking the idea from his kid's toy. He used to call that as a Hadoop, the small yellow elephant. So he picked up the idea from his kid's toy and mentioned it as a pet project to start with, and then eventually formalized as Hadoop. So that's how the Hadoop came across, and it is an open source data management, data storage, and processing platform which can scale out to unlimited needs in a distributed fashion. Okay, so as I mentioned, Hadoop primarily has two core components. One is the HDFS file system, which is a distributed file system, highly fault tolerant, capable of storing big volumes of data and providing high throughput to process and manage all the data in the distributed fashion. And the second primary component is the MapReduce aspect of it. Since we have to manage big data, we cannot handle the big data in one network storage or in one SAN storage kind of storage solution. So we need a commodity distributed solution where it acts as a file system. So HDFS plays the exact role of providing it a distributed file system on a commodity infrastructure. So MapReduce is the second part of the Hadoop where it helps to build distributed processing or distributed analytics on top of the stored information in Hadoop. So what it does is primarily, it is a programming model for large-scale data processing, so kind of MPP or kind of MPC kind of a approach. So also Hadoop contains common supported frameworks or common frameworks or ecosystem projects like Pig, Hive, Scoop, Flume. Using all these supported cross-functional frameworks, you could go and leverage and build a full-blown robust enterprise data warehouse solution. Okay, so little bit more insights into the MapReduce. So MapReduce is an expectation maximization technique where the job is split into smaller tasks so that it can be executed in a distributed fashion. When you split the bigger job into smaller tasks, it's more of a divide and conquer approach. So you can achieve X amount of work when it is split into smaller pieces. So you can divide that into X by, say, N number of pieces and achieve that in a smaller time with all the fault tolerance, the coordination, the cluster management taken care by the Hadoop framework. You need to only focus on the business logic or on the actual business aspects of the MapReduce. Okay, so quickly we'll do a comparison of Hadoop versus RDBMS. So RDBMS, you have to have a fixed schema when it comes to Hadoop, you don't need to have a fixed schema. It is all flexible. And in Hadoop, basically, you may have to do some sort of always a write operation to start with. There are few enhancements which started happening the append as well. In case of RDBMS, you can do a lot of update, read, delete operations. So some of those operations are not available in your traditional in your Hadoop platform. And also your traditional RDBMS reads are faster comparatively when it comes to Hadoop. The loads or the writes are faster. So Hadoop is fine-tuned for better performing writes, and RDBMS are fine-tuned to better performing reads. And RDBMS are based on some standards like ANSI SQL and some fixed way of defining the schema and interacting with that schema. So whereas Hadoop does not have any fixed or standards where you have to interact in this way, it is more informal, very flexible kind of interaction with the Hadoop storage and the MapReduce. So some of the differences also you would see when to use RDBMS based solution or enterprise data warehousing versus Hadoop is, say if you need to have very high performing low latency queries, so you cannot use Hadoop straightforward. And when it comes to large volumes of data and you're okay to sacrifice performance, you can go for Hadoop. And when it comes to ACID kind of features or consistency with moderate amount of data, you can choose RDBMS, not Hadoop. So when it comes to functional features like counting, sorting, cursors, triggers, joins, complex querying needs, ad hoc queries with moderate or reasonable data volume, RDBMS fits the bill with low latencies. Okay, so Hadoop really fits the bill when you have huge volumes of data, structured, semi-structured or unstructured. You need flexibility with the schema, and you need to store this data and process this data in a distributed fashion. So that's where you have to go for Hadoop. Okay. So some of the questions you might come across: why Hadoop for big data? Okay, so as I was explaining, so Hadoop provides you unlimited horizontal or scale-out aspects, and it gives you flexibility in accepting all the data formats, not just restricting it, okay, I need this data in SQL in this structured format kind of restriction. So Hadoop can accept raw data in most of the formats which is available or which is known in today's digitization world. And also it is a very efficient and simple technique which allows you to store the data in a fault-tolerant mechanism where it allows data to be redundant in the HDFS, and also it can handle fault tolerance in your distributed processing as well. More or less, it is the simplest approach comparatively when you correlate with the RDBMS-based data warehousing platforms. Not the last, but the most important thing, it can be built on a commodity hardware, which is not the case with your traditional RDBMSs. Okay, so some of the real-world examples, the Sears Holdings Corporation, the success story of Sears Holding was all going on Hadoop. So at Sears, the scale that required big data analytics and capability. So initially they were on the conventional data warehousing platform where they were using all the commercial conventional style, and CS was not able to handle the customer demand and real-time needs of running business reports and running any business promotions or business uptick kind of a situation. So due to this, CS was seeing a huge revenue loss with the competitors and their business was going down. So CS wanted to consolidate their traditional enterprise data warehousing platforms from Teradata or Oracle or SaaS kind of solutions to Hadoop. So they successfully migrated all their conventional data warehousing platforms to Hadoop, and they could see in immediate revenue savings and business growth which can do wonders in their corporation by leveraging the Hadoop platform. So this is one of the success real world stories which you guys can dig into further. Okay, so some of the things what you might also see challenged when you do a traditional or a conventional data warehousing platform is, so the first thing is you will be only storing the raw information in limited way. What I meant is when you extract or instrument lot of data from different sources, you don't store the raw data as is in conventional data warehousing platforms or solutions. We strip out a lot of data and store only what is exactly important for me to store to run those ad hoc queries. That potentially could be a problem when you have a very high fidelity raw data which is getting stripped out into low fidelity and very limited data sets. Maybe there could be a potential option to leverage cross-functional low fidelity attributes versus high fidelity attributes. Possibly we are losing all that opportunity. And the second thing is moving the data from computing storage, say for example from aggregating directly the raw data to the computing storage doesn't offer you the scale, because your RDBMS, underlying storage platform, which is RDBMS, cannot store massive scale of data. For that reason, we cannot move the direct data, the raw data into the end storage. So for that, we have to strip the data, and that storage platform also does not offer us the scalability. And the last one, the historical data, which again we keep storing it in our master storage or the data warehousing platform, has to be archived periodically. And it cannot keep on storing all the historical window of the data, so it has to be archived periodically and it goes into a premature death. So there is a lot of business value and a lot of business data which we are losing it over the period of time. So Hadoop solves all these three functional problems by storing the entire raw data as is into the Hadoop storage, and it can store unlimited data and it can store all the historical data so that you don't need to directly archive the data and constrain yourself from storing, say, only my database can store only say 10 terabytes of information. At any given point of time, if it crosses 10 terabytes, either I need to purge the old data to accommodate new data. All that scenarios is taken care by Hadoop by providing unlimited scale and unlimited storage, where you can keep on storing all the data. Even the oldest data for say 5 years old data can also be stored directly, which can be available for processing at any given point of time. Okay, so when it comes to scalability, so relational databases, you can think of interactive OLAP solution like a small sports car. And when it comes to Hadoop, Hadoop is not like a sports car. It is more of a it's more of an engine which which pulls heavy goods carriages and pulls heavy duty kind of a stuff, right? So scalability is the key aspect. It provides unlimited scale and keeps the data forever, and it does auto scale. You don't need to manage the scalability aspects of it, and it handles the commodity. It handles the scale with the commodity infrastructure. Virtually, I'll keep saying unlimited scale, but practically there would be some limit, but you can try out to whatever you would require to scale. Moreover, Hadoop offers you horizontal scale versus where RDBMS focus is on the vertical scale. So also relational databases are 100% SQL compliant, whereas Hadoop is more of a complex data, unstructured, very flexible and scalable storage, where we can go ahead and store all the information and process it in an efficient way. So apart from that, Hadoop can scale with different solutions, and it can integrate and work in a hybrid model. Comparatively, when you have to build a storage solution which is like more of a standalone solution like RDBMS, Hadoop just differentiates itself, and it can integrate with either databases or with any other big data NoSQL solutions, and it can work in conjunction. So if you take Hadoop, so Hadoop can work with HBase, which is a NoSQL offering which is built on top of Hadoop. So it can scale to indefinite or hybrid models. So it's not restricted to the cluster scaling. So it can scale to robust solution needs as well. So that's very important. So in conventional RDBMS, that's not a possibility. You have to stick to that environment or the stack what has been provided by the enterprise data warehousing solution. So you have to stick to that and you have to follow that one. Okay. The most important thing, so before we conclude, so what is that we would require to consider in what kind of situations? So that was our objective. So before we conclude, so consider data warehousing platforms built on top of RDBMS when you have to have low latency interactive reports, and you have to build a OLAP kind of an online analytic processing. Hadoop is not an online analytic processing. Hadoop is an offline analytics processing platform. So there is a huge difference, online versus offline. Hadoop cannot fill or fit the bill of online querying or interactive querying of your data. And Hadoop takes time to run the distributed processing and provide you the results. So that's where Hadoop is not the right choice if you're looking for a low latency, like I need the results or responses in 2 or 3 seconds or maximum say 5 seconds. Yes, Hadoop can work in conjunction with some of the NoSQL or RDBMSs to deliver that solution. That's where we call it as hybrid solution. So if you need a pure low latency interactive reports OLAP kind of a thing, Hadoop is not the right solution. Data warehousing said that Hadoop can also work with the conventional data warehousing, interacting and providing you the massive scale. Okay, if you have a proper ANSI SQL compliance requirement, then the data warehousing kind of solutions fits the bill rather than the Hadoop kind of a thing. Hadoop also gives you the opportunity to interact with the MapReduce using the Hive abstract interfaces, but it is not the true ANSI SQL standards compliant. So it has its own way of interacting with the Hadoop. Okay, so when it comes to volumes of the data, huge volumes of raw unstructured data, so data warehouse cannot handle this kind of situation, so Hadoop is the best choice. And when it comes to archival or storing big data for all your historical data volumes, again your data warehouse does not fit into the bill. You have to go for Hadoop kind of a platform. When it comes to high quality cleansed data, so Hadoop is capable of storing raw data as well as cleansed data. You need a very high quality cleansed data on which you can immediately query, join the data, do all sorts of relational features. So data warehousing fits the bill. And moreover, both of them supports the concurrency aspects of Hadoop in conjunction with HBase kind of technologies. And also, say for example, if you have to do a parallel processing, so let's assume you have to do a massive parallel processing, RDBMS is not the right choice. That's where Hadoop fits into the bill. And some of the differences where I have shared is basically if you have unrestricted, unstructured data, ungoverned data, so again Hadoop fits the bill. And also if you wanted to go ahead and explore something which is massive, something which is very complex, which does not fit the bill of doing a simple joins or nested joins or 3 or 4 table joins. So there are very complex data structures which you have to analyze, which you have to do. Say for example, indexing the web cannot be done on indexing the web, and providing the orders or sorting cannot be done on a relational RDBMS. So you have to do it in kind of Hadoop kind of a platform. When it comes to recommendations on Amazon, YouTube, again those kind of things cannot be done on a straightforward RDBMS. It has to be done on Hadoop. So that's just to keep time check. So that's pretty much when you have to go for Hadoop and what you have to consider choosing the right solution. So being said that, I would keep the last couple of minutes for any Q&A. I'll see if I can take them, one or two of them, and see if I could.
Thanks for the insightful presentation, Madan. As you have just mentioned, let's quickly take up the questions now. I have to request you to read out the questions and their answers so that all our users may listen to your insights. So are you able to see some of the questions come into your questions doc?
Yeah, so I'll pick some of the interesting questions. So one of the questions from Utsav Verma is, if an organization is dealing with less than 1 terabyte of data, then would relational database be better? Absolutely, you're right, Utsav. So there is no point in storing or building big data clusters of Hadoop clusters just to store and work with 1 terabyte of information. So if your data size is just less than, say, 5 to 6 or 10 terabytes, it doesn't make any sense. So more than, like, my personal recommendation is, if you have data volumes of more than 50 to 60 terabytes, go and look for a Hadoop kind of a solution. If it is like 1 or 2 terabytes, stick to RDBMS solutions that fits and that fulfills your needs pretty much. Okay, so I'll pick one more question, interesting question from Ankur. MongoDB versus Hadoop for big data. Why Hadoop can capable than MongoDB? Okay, great question. As I mentioned, MongoDB and Hadoop, they again solve two different purposes, just like Hadoop and RDBMS. You cannot compare MongoDB versus Hadoop. MongoDB is a OLTP NoSQL database which can support big data scale, and Hadoop is a offline analytics platform which can support big data. So they are two different technologies, so I would recommend not to compare these two technologies. Okay, so since I could see a lot of questions being streamed, so what I would do is we will persist all these questions, and you could use the edureka staff, the Twitter handle, to post all your questions, the current questions as well as the future questions, and they'll get back to you on your queries and your concerns so that we could help you out in getting better understanding of it. So being said that, I would also briefly recommend you to check out the edureka portal, the sponsor of this webinar. So they have got some nice coverage of courses on Hadoop. So you may get further details or insights if you wanted to explore the courses. I could just quickly show you the portal so you can check it out on your free time. Okay, so I'll leave it up here for now. I'll ask the remaining questions to be channeled through the edureka Twitter handle, and they will get back to you guys. Thank you everyone, and thanks for your time, and thanks for attending the Hadoop session, and I hope you guys liked it.